Picture this. It's 1978 in rural Pennsylvania, and a dairy farmer stares at a broken-down Caterpillar bulldozer in a scrapyard. Most people see junk metal. Earl Schrock sees the solution to a problem that John Deere said couldn't be solved. What he did next would force one of agriculture's biggest companies to completely reverse their engineering philosophy. This is the story of how a farmer with a wrench outsmarted an army of engineers. The morning of April 15, 1978, started like any other on Earl Schrock's 450-acre dairy farm near Lancaster, Pennsylvania. Spring plowing season was here, and Schrock faced the same challenge that had plagued him for years. His John Deere 4430 tractor, the backbone of his operation, simply didn't have enough power. At 125 horsepower, it could pull a 5-bottom plow through his heavy clay soil, but only by crawling along at speeds that turned a day's work into a week's marathon. Every other farmer in the county faced the same limitation. You either bought a bigger tractor for $15,000 or you accepted that plowing would eat up most of your spring. But Earl Schrock wasn't every other farmer. He'd spent 20 years as a diesel mechanic before taking over the family farm, and he understood something that seemed to escape the engineers at John Deere's Waterloo, Iowa headquarters. The problem wasn't the engine itself. The 404 cubic inch diesel in his 4430 was bulletproof, a masterpiece of agricultural engineering that could run for decades with basic maintenance. The problem was how that engine breathed. To understand what Schrock saw that John Deere didn't, we need to talk about the state of agricultural technology in the late 1970s. This was the twilight of the naturally aspirated era in farm equipment. Tractor manufacturers, led by John Deere, International Harvester, and Case, built their reputation on simplicity and reliability. Their philosophy was straightforward. Farmers needed equipment that could survive dust, mud, temperature extremes, and inexperienced operators. Every additional component was another potential failure point. The John Deere 4430, introduced in 1973, embodied this philosophy perfectly. Its naturally aspirated 6-cylinder diesel produced its power through displacement and compression alone. No turbochargers, no intercoolers, no complex boost control systems, just pistons, valves, and cast-iron reliability. The engine breathed at atmospheric pressure, 14.7 psi, at sea level, drawing in exactly as much air as the pistons could naturally pull. It was simple, predictable, and according to John Deere's engineers, exactly what farmers needed. The corporate stance was clear and had been communicated through dealer networks and agricultural publications. Turbocharging, they argued, belonged on highway trucks and construction equipment where trained mechanics performed regular maintenance. Farm tractors operated in dusty fields were maintained by farmers with varying mechanical skills and needed to start reliably, whether it was -20 in January or 95 degrees in August. A turbocharger spinning at 100,000 RPM would never survive that environment. At least, that's what they believed. Earl Schrock disagreed. And on that April morning, staring at his underpowered 4430, he decided to prove them wrong. The journey to Keystone Salvage Yard took 45 minutes through Pennsylvania's rolling farmland. Schrock wasn't going there by chance. He'd been studying turbocharger applications in industrial equipment for months, reading technical manuals, and most importantly, talking to heavy equipment operators. The Caterpillar D6 bulldozer that caught his attention had been written off after a transmission failure, but its turbocharger was intact. The Garrett T04B Turbo was designed for a 636 cubic inch Cat diesel, significantly larger than his John Deere's 404 cubic inch power plant. Conventional wisdom said it was too big. Schrock saw opportunity. The turbocharger itself was a thing of beauty, even covered in grease and dirt. The cast iron housing contained a turbine wheel on one end and a compressor wheel on the other, connected by a common shaft. Exhaust gases would spin the turbine at speeds up to 120,000 RPM, which would drive the compressor to force additional air into the engine. More air meant more fuel could be burned. More fuel burned meant more power. The physics were simple. The execution would be anything but. Schrock paid $200 cash for the turbocharger, another $50 for assorted piping and clamps, and headed back to his farm's workshop. What happened over the next 6 weeks would become legend in the farming community, though John Deere would prefer you never heard about it. The first challenge was fabrication. The 4430's exhaust manifold was never designed for turbocharger mounting. Schrock spent 3 days with a cutting torch and arc welder, creating a custom manifold from scratch using 1/4-inch steel plate. The angles had to be perfect, too sharp, and exhaust flow would be restricted, too shallow, and the turbo would sit too high, interfering with the hood. He built and rebuilt the manifold 3 times before getting it right. Next came the mathematics of fuel delivery. A naturally aspirated diesel operates at a specific air-to-fuel ratio, typically around 18.1 for optimal combustion. Adding boost pressure would increase air density, requiring proportionally more fuel to maintain the correct ratio. Too little fuel and the engine would run lean, potentially melting pistons. Too much and it would belch black smoke while washing cylinder walls with unburned diesel. The 4430's mechanical injection pump, a Bosch inline 6-cylinder unit, had no idea a turbocharger existed. It would deliver the same amount of fuel regardless of boost pressure. Schrock needed to modify it, but John Deere didn't exactly publish instructions for hot rodding their injection pumps. He turned to an unlikely source: truck pullers. The competitive truck pulling community had been turbocharging diesel engines for years, pushing them to outputs that manufacturers never imagined. Through connections at a regional pull in Bloomsburg, Schrock learned about shimming delivery valves and adjusting governor springs. The modifications were precise work. Each delivery valve required a 0.030-inch shim to increase fuel delivery by approximately 28%. The governor spring tension was increased by adding a second spring in parallel, raising the maximum RPM from 2,200 to 2,400. But the real innovation came in boost control. Without any form of wastegate or boost regulation, the turbocharger would build pressure until something failed, likely catastrophically. Schrock's solution was elegantly simple: a modified tractor tire pressure relief valve set to 18 psi. When boost exceeded that threshold, the valve would vent excess pressure to atmosphere. It wasn't sophisticated, but it was bulletproof. The oil system presented another puzzle. Turbochargers require continuous lubrication, with oil serving both to lubricate the shaft bearings and carry away heat. The 4430's oil system operated at 60 psi, perfect for engine bearings, but potentially too high for the turbo's more delicate journals. Schrock installed an adjustable restrictor in the oil feed line. A brass fitting he machined himself on a 40-year-old South Bend lathe. The return line was simpler, gravity feeding back to the oil pan through a fitting he welded below the oil level. By late May, the installation was complete. The moment of truth came on a humid Thursday morning with his son, David, and neighbor Tom Muller as witnesses. The first start was anticlimactic. The engine fired normally, idled smoothly, and showed no signs of the radical surgery it had undergone. The turbocharger, sized for a much larger engine, barely spun at idle. Then Schrock pushed the throttle forward. The transformation was immediate and shocking. As RPM climbed past 1,400, the turbocharger began to spool. The characteristic whistle grew louder, joined by the rush of compressed air. By 1,800 RPM, the boost gauge Schrock had installed showed 12 psi. At full throttle, 18 psi. The engine note changed completely, from the traditional diesel clatter to something deeper, more authoritative. Diesel smoke, normally black and heavy under load, was nearly invisible. The real test came in the field. Schrock hitched up his 5-bottom John Deere 555 plow and headed to his North 40, a field known for heavy clay soil that turned to concrete when dry. Normally, he'd run in third gear at barely 4 miles per hour to pull through this ground. With the turbo spooled, he shifted to fifth gear and maintained 6 miles per hour with power to spare. The tachometer showed 1,900 RPM, where it would have been lugging at 1,600 before. Tom Miller, who owned the adjacent farm, couldn't believe what he was seeing. His identical 4430 would bog down in the same field, requiring multiple passes to achieve what Schrock's modified tractor did in one. Word spread through the farming community like wildfire. Within a week, farmers from 3 counties were showing up at Schrock's workshop to see the impossible machine. The performance gains were staggering. Dynamometer testing at a regional equipment dealer showed 195 horsepower at the PTO, up from the stock 117. Torque increased from 340 pound-feet to 485, but the real advantage was in the torque curve. The turbocharged engine maintained peak torque from 2,400 to 2,100 RPM, a massive plateau that allowed the tractor to power through varying loads without constantly shifting gears. Fuel consumption, surprisingly, decreased during heavy tillage operations. The stock 4430 burned approximately 7.8 gallons per hour, pulling a 5-bottom plow. The turbocharged version burned 8.2 gallons per hour, but covered 60% more ground in the same time, resulting in a net efficiency gain of 35%. At 1978's diesel price of 65 cents per gallon, the modification would pay for itself in a single plowing season. But would it last? That was the million-dollar question, and the one John Deere's engineers would have answered with an emphatic no. Turbochargers in agricultural applications faced unique challenges. Unlike highway trucks that operated at steady speeds on clean highways, tractors worked in clouds of dust, chaff, and dirt. The air filter on Schrock's 4430 needed cleaning daily during harvest season. How could precision rotating equipment survive that environment? Schrock's answer was meticulous maintenance and clever engineering. He installed a pre-cleaner on the air intake, a centrifugal separator that removed 90% of large particles before they reached the main filter. The turbocharger's compressor inlet was shielded with fine mesh screen, preventing straw and leaves from entering. Most importantly, he religiously followed a 10-minute cool-down procedure after heavy work, idling the engine to allow the turbo to cool before shutdown. The injection pump modifications raised other concerns. Increasing fuel delivery put additional stress on internal components designed for specific loads. The pump's cam ring, delivery valves, and plungers were operating outside their design envelope. Would they fail prematurely? Schrock addressed this by using premium diesel fuel with additional lubricity additives and changing the injection pump oil every 100 hours instead of the recommended 500. As summer turned to fall, the turbocharged 4430 continued to exceed expectations. Harvest season, traditionally the tractor's toughest test, came and went without incident. The turbo pulled a 3-row corn picker through fields that would have required multiple passes before. It powered a hammer mill that previously needed a larger tractor. Neighbors who initially predicted catastrophic failure were now asking for Schrock's help with their own modifications. The economic impact was undeniable. A new John Deere 4630 offering 150 horsepower listed for $32,000 in 1978. A 4840 with 180 horsepower cost $41,000. Schrock had achieved better performance than either for less than $500 in parts. The labor was his own, approximately 60 hours spread over 6 weeks. Even paying shop rates of $20 per hour, the total investment would have been under $2,000. But this wasn't just about one farmer saving money. Schrock's modification challenged the entire agricultural equipment paradigm. If a dairy farmer with basic tools could dramatically improve a tractor's performance, What did that say about the manufacturer's engineering decisions? Were they deliberately holding back technology to sell more expensive models? Or had they simply become too conservative, too afraid of warranty claims to innovate? The truth was more complex. John Deere's engineers weren't incompetent or malicious. They were designing for the lowest common denominator, the farmer who might go entire seasons without checking oil levels, who would run equipment until it broke rather than performing preventive maintenance. Their naturally aspirated engines could survive this neglect. A turbocharger couldn't. Internal documents from John Deere, later revealed through dealer service bulletins, showed the company was well aware of turbocharging's potential. They had tested turbocharged prototypes as early as 1975, but reliability concerns, particularly regarding air filtration and heat management, led them to delay implementation. They were also concerned about dealer service capabilities. Most rural dealerships lacked technicians trained in turbocharger diagnosis and repair. Schrock's success forced a reconsideration. Here was proof that turbocharging could work in agricultural applications, provided the operator understood the technology and maintained it properly. The pre-cleaner and extended maintenance intervals weren't revolutionary concepts. They were common-sense applications of existing technology. The modified injection pump, while technically complex, used principles that diesel mechanics had understood for decades. Word of Schrock's modification reached John Deere headquarters through an unusual channel. Robert Hansen, a regional sales manager based in Moline, Illinois, heard about it from a dealer in Harrisburg, Pennsylvania. The dealer reported losing 3 tractor sales to farmers who decided to modify their existing equipment instead. Hansen drove to Pennsylvania to see for himself. The meeting between Hansen and Schrock, documented in Hansen's field notes, was cordial but tense. Hansen warned about warranty implications and potential safety hazards. Schrock responded with dynamometer sheets and maintenance records. The tractor had accumulated 800 hours since modification without a single turbo-related failure. Every wear indicator, from compression tests to oil analysis, showed the engine was healthier than stock examples with similar hours. Hansen left Pennsylvania with mixed feelings. As a company man, he couldn't endorse unauthorized modifications. As an engineer, he was impressed. His report to Waterloo recommended accelerating the company's turbocharger development program. The market was ready, he argued, and if John Deere didn't provide factory turbocharged options, farmers would create their own. The autumn of 1978 brought unexpected validation. The Farm Progress Show in Decatur, Illinois, was the agricultural industry's premier showcase for new technology. While John Deere displayed their latest naturally aspirated models, Schrock's turbocharged 4430 drew crowds at a nearby demonstration plot. He wasn't an official exhibitor, just a farmer who'd driven his tractor from Pennsylvania to prove a point. The demonstration was devastating to the established order. In side-by-side tillage trials, Schrock's modified 4430 outperformed stock 4630s and matched 4840s, costing twice as much. It pulled a 7-bottom plow through heavy soil that stopped naturally aspirated tractors cold. The turbocharger's whistle became the soundtrack to a revolution in agricultural thinking. Industry journalists took notice. Wallace's Farmer ran a feature titled "The Farmer Who Outsmarted Deere." Progressive Farmer published detailed photographs of the modification. Farm Journal interviewed Schrock about his maintenance procedures. The coverage was overwhelmingly positive, portraying him as a David taking on corporate Goliaths with ingenuity and determination. Competitors watched with interest. International Harvester had been experimenting with turbocharged tractors since 1976, but reliability issues plagued their early attempts. Alice Chalmers offered turbocharged models, but with conservative boost levels that limited performance gains. Case was developing their Magnum series with turbocharging as a cornerstone feature. Schrock's success suggested the market was ready for forced induction, provided it was implemented correctly. By winter, Schrock had become an inadvertent consultant. Farmers from across the Midwest sought his advice on turbocharging their own tractors. He helped establish basic principles. Proper oil supply was critical, air filtration couldn't be compromised, and cool-down procedures were mandatory. He also warned against excessive boost. Several farmers who ignored his 18 psi limit suffered melted pistons and cracked heads. The economic ripple effects were significant. Salvage yards reported increased demand for turbochargers from agricultural customers. Performance diesel shops, previously focused on truck pullers, expanded into agricultural modifications. A cottage industry emerged around supplying components and expertise for tractor turbocharging. John Deere's response came faster than anyone expected. In January 1979, they announced a new option package for the 4440 and 4640 models, factory turbocharging. The press release didn't mention Earl Schrock, but industry insiders knew the connection. The factory turbos were more sophisticated than Schrock's modification, featuring wastegates, aftercoolers, and revised injection systems, but the basic concept was identical to what a Pennsylvania dairy farmer had proven in his barn. The pricing was revealing. The turbocharger option added $3,200 to a tractor's base price, a significant premium over Schrock's $500 modification, but it came with warranty coverage, dealer support, and the peace of mind that everything was engineered to work together. Most farmers considered it worthwhile, though some continued to pursue aftermarket modifications. Schrock's influence extended beyond John Deere. By 1980, every major tractor manufacturer offered turbocharged models. The technology that had been deemed too complex for agricultural use just 2 years earlier was now standard on high-horsepower tractors. The transformation was complete, and it started with one farmer who refused to accept conventional wisdom. The technical evolution was fascinating to observe. Factory turbochargers incorporated lessons from Schrock's experience. Pre-cleaners became standard equipment. Oil cooling systems were upgraded to handle increased heat loads. Injection pumps were redesigned for variable fuel delivery based on boost pressure. Air-to-air intercoolers, technology borrowed from highway trucks, appeared on top-tier models. But perhaps the most important change was philosophical. Manufacturers realized that farmers were more technically capable than they'd assumed. Given proper information and support, agricultural operators could maintain complex systems. The key was education, not simplification. Dealer training programs expanded to include turbocharger theory and maintenance. Owner's manuals grew from basic operation guides to comprehensive technical resources. Schrock's tractor continued working through the 1980s, accumulating hours that would have retired most machines. By 1985, it had logged over 5,000 hours with the original turbocharger. The only major repair was replacing shaft seals at 3,200 hours, a $20 parts kit, and 2 hours of labor. The engine itself showed minimal wear, compression testing within 5% of factory specifications. The longevity surprised even Schrock. He'd expected to rebuild the turbocharger every few seasons. Instead, it outlasted many stock components. The secret was consistent maintenance and respecting operating limits. While other farmers pushed modified tractors to destruction chasing maximum power, Schrock understood that reliability required restraint. By 1990, the tractor had become something of a celebrity in agricultural circles. It appeared at vintage tractor shows, not as an antique, but as a testament to innovation. Young farmers who'd grown up with factory turbocharged tractors were amazed that such modification was once considered impossible. Older farmers remembered the skepticism and resistance that Schrock had overcome. The economic analysis conducted by agricultural economists at Penn State University was striking. Schrock's modification had saved him approximately $15,000 in 1978 versus buying a comparable, higher horsepower tractor. Adjusted for inflation, that's nearly $70,000 in today's money, but the productivity gains were even more valuable. The increased plowing speed and pulling capacity had allowed him to expand his operation without additional equipment. The broader impact on American agriculture was profound. Turbocharging enabled the trend toward larger, more powerful tractors that could handle massive implements. This increased efficiency contributed to declining food costs relative to income throughout the 1980s. While multiple factors drove this trend, the widespread adoption of forced induction was a significant contributor. John Deere never officially acknowledged Schrock's role in their turbocharger development. Corporate history presents it as natural evolution, engineers responding to market demands for more power. But veterans of the Waterloo engineering team tell a different story. They describe emergency meetings after the 1978 Farm Progress Show, heated debates about warranty implications, and ultimately, grudging respect for what one farmer had accomplished. The patent situation was interesting. Schrock never attempted to patent his modification, viewing it as an application of existing technology rather than an invention. John Deere's subsequent patents on agricultural turbocharging systems carefully avoided claiming the basic concept, focusing instead on specific implementation details. The legal department understood that prior art, demonstrated very publicly by Schrock, would invalidate broad claims. In 1998, 20 years after the original modification, Schrock's 4430 finally retired from active service. It had accumulated 15,000 hours, equivalent to driving a car 750,000 miles. The original turbocharger, rebuilt twice but never replaced, still functioned. The engine had never been overhauled, a testament to both John Deere's fundamental engineering and Schrock's careful modification. The tractor now resides in the Pennsylvania Farm Museum, donated by Schrock with the stipulation that it remain operational. Visitors can see the hand-fabricated exhaust manifold, the salvage yard turbocharger, and the pressure relief valve that revolutionized an industry. A placard explains the technical details, but it barely captures the audacity of what Earl Schrock accomplished. The lessons extend beyond agriculture. Schrock's story demonstrates that innovation doesn't require massive research budgets or advanced degrees. Sometimes it requires someone willing to challenge accepted wisdom with practical experimentation. He proved that end users often understand their needs better than manufacturers. Most importantly, he showed that technology deemed too complex for certain applications might just need better implementation. Modern agricultural equipment has evolved far beyond what Schrock could have imagined. Today's tractors feature variable geometry turbochargers, electronic boost control, and sophisticated engine management systems. GPS guidance and automated implements have transformed farming into precision agriculture. But the foundation, the idea that farm equipment could handle advanced technology, traces back to a Pennsylvania workshop in 1978. The human element remains crucial. Earl Schrock wasn't trying to revolutionize agriculture. He just wanted to plow his fields faster, but his willingness to experiment, to risk his expensive tractor on an unproven modification, changed an entire industry. He proved that farmers were engineers too, capable of innovation that matched or exceeded what came from corporate research centers. The story also highlights the danger of institutional blindness. John Deere's engineers weren't wrong about turbocharger complexity. They were wrong about farmers' ability to manage that complexity. They underestimated their customers, assuming that simplicity was more important than capability. Schrock proved that given the choice, farmers would choose power and efficiency, even if it required additional maintenance and understanding. Today, Earl Schrock, now in his 80s, still lives on the same farm. He's witnessed the complete transformation of agricultural technology, from mechanical injection to common rail systems, from naturally aspirated to multi-stage turbocharging. When asked about his contribution, he's characteristically modest. He was just solving a problem, he says, doing what farmers have always done, making do with what's available. But the impact is undeniable. Every turbocharged tractor working fields across America carries a bit of Schrock's DNA. The massive machines pulling 30-row planters at speeds that would have seemed impossible in 1978 exist because one farmer proved that turbocharging could work in agriculture. He didn't just modify a tractor, he modified an industry's understanding of what was possible. The technical specifications tell only part of the story. Yes, Schrock increased horsepower from 125 to 200. Yes, he achieved this for $500 versus $15,000. But the real achievement was psychological. He broke the barrier between what manufacturers provided and what farmers could create. He proved that innovation could come from anywhere, that practical experience could trump theoretical concerns. The relationship between manufacturers and customers changed after Schrock's modification. Companies realized they needed to listen more carefully to end users, to understand not just what customers said they wanted, but what they were trying to achieve. The adversarial dynamic, where manufacturers dictated capabilities and farmers simply accepted them, gave way to a more collaborative approach. This transformation wasn't immediate or universal. Many dealers initially resisted supporting modified tractors, fearing liability and warranty complications. Some farmers who attempted modifications without Schrock's methodical approach suffered expensive failures. But the genie was out of the bottle. Farmers had seen what was possible, and they wouldn't accept artificial limitations anymore. The story of Earl Schrock's turbocharged tractor is ultimately about American ingenuity, the willingness to challenge authority with practical results. It's about understanding technology well enough to adapt it to new purposes. It's about the democratization of innovation, proving that breakthrough improvements don't require corporate laboratories or government funding. Sometimes they just require a farmer with a problem, a salvage yard with a solution, and the courage to put them together. What do you think about manufacturers who underestimate their customers' capabilities? Have you ever modified equipment to exceed its original specifications? Share your thoughts in the comments below, and don't forget to subscribe for more stories of engineering innovation that changed entire industries. Until next time, keep questioning what's possible.